Hello everybody, it's still the same paper 1. We are continuing now with question 14. Now question 14 reads, an open-topped fish tank is to be made for an aquarium. It will have a square horizontal base, rectangular vertical sides and a volume of 60. The materials cost would be £15 per meter squared for the base, £8 per meter squared for the sides. We are now to model the sides and the base of a fish tank as laminae and use calculus to find the height of the tank for which cost would be at its lowest value. So if you are going to have to find the point at which cost would be at its lowest, dependent on the height, you need to find the minimum point of f of x. But it's not just f of x now, it's c of h. So you would need to write a function c, which stands for cost, in terms of height, okay, and then if that gives you height squared plus 7 height whatever, then you can now find c dh of this, which is 2h plus 7, equated to 0, and whatever the value of height is, okay, this cannot be negative anyway, but whatever the value of height is the point where it's either a maximum or a minimum. So we need to come up with a relationship between cost and height of the tank. So first we're told to model this thing, so we're just going to do that. So the first thing is that it has a square base. So the base is a square and it has rectangular sides. So I'm just going to make it so simple. We are drawing a laminae. So that's what you get when you spread out the tank, when you open it flat. It has no top, so there will be no covering. Otherwise I could have had a top cover also drawn out like that, so that when you close it, it becomes sealed. But we don't have a top, so that's fine. The base, let's say it has sides of, well, lengths of x on the sides, and of course that would also be the length of the sides. And for the height, which is that, the thickness, that's what it is really. We have that. Okay, so what's going to be the cost? The cost of this is going to be the cost of the base plus the cost of the 4 sides. So it is cost of base, it's just one base, plus cost of the 4 sides. Now, how do we get, so that's C, right? How do we get the cost of the base? It says that the base is £15 per meter squared. So that means £15 for each meter squared. But how many meters squared do we have? That is, what's the area of the base? The area of the base is x squared, because length times length is the area of a square. So that's 15x squared. Right, plus the cost of 4 sides. The cost of 4 sides will be 4 times the cost of 1 side. Now, the price of 1 side is £8 for a meter squared. So for a meter squared, you'd spend £8. What's the area of the side of 1 side? The area of 1 side is length times width, so that's x times h. So £8 for the area of 1 meter squared, and then when you have an area of xh meters squared, the total would be 8xh. But you need 4 of them because you have 4 sides, and so that's 4 times it. So cost is therefore 15x squared plus 32xh. Now this is the relationship between the cost and the sides as well as the length, something like that, the height and the length. But we want to have something that relates cost to height and height only. We don't want x involved. So how can we relate x and h? The question clearly said to us that the volume is 60 meters cubed, right? So if the volume has to be 60, what does that mean in terms of X and H? What is the volume of a tank? It's the area of the base times the height of the tank. So the area of the base is the area X squared for that, and the height is the H. And if that has to be 60, can we therefore replace X in terms of H? So X squared is 60 divided by H, while X is going to be square root of 60 over H. So can we throw this into the formula for C so that we know what we are doing? Alright, so C is now going to be 15x squared. This x squared would be given as 60 over H. So times 60 over H plus 32 times x times H. Now the x there would be replaced by root 60 over H. I'm going to write this in a fresh sheet so you can see clearly what I've written. C equals 15 multiplied by 60 over H plus 32 multiplied by root 60 over H, then times H. In order to simplify this, we would say 15 times 60 is 900, so C equals 900 H to the negative 1 plus 32 times square root of 60 over root H times H. Okay, root H at the bottom there would go into H to give you another root H, because H means root H root H. So if you divide H by root H, you simply caused one of them to go. So this would give you H to the power half. So C is therefore 900 H to the minus 1 plus 32 root 60 H to the half. So this is the relationship now between C and H. What we need to do to find the minimum value for the minimum point of this relationship will be to differentiate it. So I just need to do dc dh and equate that to 0. So dc over dh, this is differentiation, multiply by the power, take 1 away from the power. So when you multiply 900 by this power, it becomes minus 900. And when you take 1 away from the minus 1 power, it becomes minus 2. Plus, you multiply this coefficient by the power, which is half. So if you multiply 32 root 60 by half, you get half of that, which is 16 root 60. And then when you take 1 away from that power, it becomes h to the negative half. Now that is the derivative of c with respect to height. In order to find the minimum point, we always equate the derivative to 0. So in doing that, I would say dc dh equals 0, and therefore negative 900 h to the minus 2 plus 16 root 60 h to the minus half is equal to 0. Of course, at this point, we just need to solve for h. Now, I don't want you to think it's complicated. It isn't complicated. I will rewrite this as fractions rather than negative powers so that it becomes something we can play around with. Okay, so we said minus 900 over h squared plus 16 root 60 over root h equals 0. Multiply both sides by h squared so that we don't have that any longer. So when you multiply by h squared all through, you have minus 900, you have 16 root 60, and this is h to the power 1.5, and then you have 0 there. And that's what I got by multiplying both sides by h squared. So that's if you multiply this by h squared and you multiply this by h squared. The h squared cancels the h squared, whereas this is 2 minus a half, and that's 1.5. So rewrite this by making h the subject. So 16 root 60 h to the 1.5 is 900. H to the 1.5 is 900 over 16 root 60, and therefore h would be the 1.5 root of 900 over 16 root 60. I have deliberately left it this way because our calculators can always do something as complex as that. So you do know how to use the calculator for this, right? So 900 over 16 root 60. First and foremost, I'll do 16 root 60. Can you even see it? All right, 16 root 60. Okay, this isn't working. Is that? Aha. So 900 divided by the answer is that square root? No, not square root. 1.5 root. So 1.5 root. Wait. Oh, shift and that. So 1.5 root of the answer is given as 3.75. Okay, 3.75. And that is the answer you have there. So h is 3.75. Now, with h being 3.75, and that's the only answer, we could check to see if this could have been a minimum point or a maximum point, and that's only obtained when you do the second derivative. Okay, so that's necessary for the 8 marks. So we go on to say, to prove that this is the minimum point, let's find d squared c dh squared. We're going to find that and slot in this height into it to see if it gives us a positive. If it gives a positive, then it's truly a minimum point. So, do we know what dc dh is? Yes, we do. Back to this, dc dh was that. So the second derivative, I'll just do that underneath here. So the second derivative definitely would be you multiply negative 900 by this power. So the CDH, this squared CDH squared would be 1800 h to the minus 3, because you take 1 away from the power, and you do the same to that, multiply this by the new power. So that's half of that again with a negative there. So negative 8 root 60, and you take 1 away from that power, so it becomes h to the minus 1.5. Okay, so this is the second derivative. We need to slot in 3.75 as the h. So if we are to do that, we would get d squared c dh squared at h equals 3.75 will be equal to, and then of course with our calculators we can always do this, so 1800 over 3.75 cube minus 8 root 60 over 3.75 to the power 1.5. Okay, now this is something you should probably do without even looking at the video at this point. Just on your calculators to test if it's a positive value or a negative. It's definitely looking positive to me. Minus 8 root 60 over 3.75 to the power 1.5, and it's a positive, so the answer is 2.56. So this gives 2.56. Okay, so this gives 2.56. It's positive. And because it's positive, therefore, H equals 3.75 is a minimum point. And that's the answer. And that's in meters. So you need to keep it as meters. Okay. If you struggle to understand this, just give me a shout, okay? And I probably would look for a better way to break it down for you. But that's it, Max. So yeah, it's cool. Now the question carries on with a simple test case. It says, in reality, the thickness of the base and the sides of the tank is 2.5 centimeters. So in reality, we have some extra thickness for the base and for the tank. Briefly explain how you would refine your modeling to take account of the thickness of the sides and base of the tank. And it's just 1 mark. So if you are told to explain how you would refine your modeling, that's taking you back to the laminate drawing that we had. So if you look at this laminate drawing, you would see that we just pretended as if at this edge you had crossover from the base to the tank straight away, to the side straight away. Ideally, there should be some extra cushion between the base and the side, or some kind of thickness. So what you would expect in a real life situation is that this base would not start from the, it's not a plain sheet. So there's going to be that extra height, which is the thickness of the base, on which the sides would sit. It's going to be like a layer higher than the ground, obviously. And that would be there. It would also be here. And so whatever height you had thought this was, it would have to start from there, because now it's been pushed up by the thickness of the base. And also, of course, that would apply to all of them. Now this is just me explaining to you. It has nothing to do with the answer yet. Of course, so that's because of the extra thickness of the base. And also because the sides also have some thickness, that would also add to the overall amount of material that you would need. So all we need to tell them is that we would refine the model to include the extra thickness on all the sides. We would also refine the model to change the total formula for the formula for the total area to include the area of the 2.5 times x, because that's 2.5 times x, 2.5 times x, 2.5 times x, 2.5 times x, and that has to be included in the area of the whole shape. So that has to do material, doesn't it? Okay, now the next thing says, how would your refinement affect your answer to part A? Well, if we later found out that we needed more materials for both the base and the sides, definitely cost would go up, right? So the minimum cost would change, and that should affect the value for the height, because now we are going to be having a different formula altogether. The volume formula would no longer just be x squared h. It's going to have to be x squared h plus the volume that the thickness has added to this tank. So the only way this would affect it is that it would make the cost go higher, and it would make the value for h go higher as well. H would definitely need to change. It will probably just be h plus 2.5, because that's only what affects, that's the only thing. Alright, so we go to question 15 now, which looks like an interesting question for 7 marks. It says, the height x meters of a column of water in a fountain display satisfies the differential equation dx dt equals 8 sine 2t over 3 root x. T is the time in seconds after the display begins. Solve the differential equation given that initially the column of water has 0 height. Now that's giving you some boundary conditions, and that means you're about to integrate. You're about to do some integration, so you need those boundary conditions to help you get your arbitrary constant C. But it's okay, we'll do it. dx over dt has been given as 8 sine 2t over 3 root x. Now please pay attention to what I'm about to say. You have t and x. Both of them are variables, okay? So this is an interesting situation. It's not quotient rule. It's not quotient rule because the function at the top is not a function of x. The function at the bottom is not a function of t. So they are separate functions. They are not the same kind of function that you can just use quotient rule. What am I even saying? We're about to integrate, right? So it doesn't even have anything to do with quotient rule. So what you need to do is to separate the variables. So we call it variable separable. Variable separable. So that means you separate the variables. So let the guys that have x go together. Let the guys that have t go together. Okay? So 3 root x goes there. So 3 root x dx goes to the left. And of course dt travels all the way to the top. So you have 8 sine 2t dt. You can call it the skull and bone method. You can call it cross multiplication. I don't know. You can call it whatever you want. It's just collecting like terms, really. Now that we have this written, we can be kind enough to put an integration symbol there to show that we are about to integrate both sides. Of course, this is just 3 times x to the power half. So everyone should be able to integrate something like that. And this is 8 sine 2t dt. Everyone should be able to integrate something like that. Now, you would agree with me that when we integrate, we always try to put our arbitrary constant. You don't need to put 2 different arbitrary constants. You can just put 1 arbitrary constant on the right hand side. So I am going to integrate this without putting any plus c. I'm going to integrate this and I'll write plus c. 1 arbitrary constant covers all. So when you integrate this, don't forget, it means you'd add 1 to the power and divide by the new power. So 3x to the power, this is 0.5, so you add 1 to the power, so that's 1.5. Divide by the new power, which is 1.5. I'm not going to put plus c there. This has an 8 in front of it, that's okay. Now, I probably would need to sit down with you guys to discuss how to integrate not chain rule, by substitution. But at this point, I am not going to explain it to details. All I would say to you is this. You have integration of sine 2t, right? 2t is not just t, it's a 2 times a t. If you differentiate 2t with respect to t, what would you get? 2. That goes at the bottom. Now let's pretend it's just a normal integration thing now. What's the integral of sine? It is negative cosine. Okay, so that's negative there, and then cosine of 2t. We would consider 2t as just 1 now because we have been able to sort it out using this derivative there. And remember what I said, plus c. Okay, 1.5 goes in 2 times, so that's 2 x to the power 1.5. I could actually call it x to the power 3 over 2 equals negative 4 cos 2t plus c. Now, it's not enough to stop there. We need to find out c. We need to work out c. And that's why we've been given the initial condition. So they said to us that it has a 0 height initially. So that means at the time t equals 0, the height was also 0. So when t is 0, x is 0. So we can we can slot those values in and see what c becomes. 2x to the power 3 over 2 equals minus 4 cos 2t plus an arbitrary constant c. When t was 0, x was also 0. So 2 to the power 0 is equal to minus 4 cos twice of 0 plus arbitrary constant c. 2 times 0 to the power anything is just 0. 2 times 0 there is 0. Cos of 0 is 1. Negative 4 times 1 is negative 4. So take note, cos of 0 is 1. You can use your calculator to verify that. And then plus c. So if you look at that critically, you'd see that therefore c equals 4. If c is 4, that means, going back to our equation, it says 2x to the power 3 over 2 equals c, which is 4, minus 4 cos 2t. I would like to make x the subject as we've been asked to do in the question, and that's by dividing both sides by 2. So x to the power 3 over 2 now becomes 2 into bracket 1 minus 2, sorry, 1 minus cos 2t. Now, don't be worried about how I did this. I took out the 4 and it became 4 into bracket 1 minus cos 2t. And I had to divide both sides by 2, so that knocks the 4 down to a 2. But we're meant to make x the subject, so it's as simple as making taking 2 over 3 power of both sides. So that's 2 to the power 2 over 3. 1 minus cos 2t to the power 2 over 3 as well. So that's the flipping of that power. Okay, I think I'm being too fast with my explanation now. Let me slow down a bit. So that's the final answer, but let me slow down a bit to tell you how we did it. If I have a to the power 3 over 2 equals 4, and someone says find a, what I will do is to raise both sides to the same power. And the power I'm going to raise both sides to is the flip of that fraction. So 2 over 3, 2 over 3. And that's because when you raise a power to another power, you simply multiply those powers. And funny enough, 2 over 3 and 3 over 2 would knock out as 1. So that leaves you with a on this side and 4 to the power 2 over 3 on the other side. And that's the answer. So that's exactly what we did here. We had x to the power 3 over 2 equals all that. We knocked the 3 over 2 by raising this to a power 2 over 3, and that knocked out the 3 over 2 from the left, and it remained on the right hand side. So that's it. And that's question 15, Roman 15a. The next bit says, find the maximum height of the column of water given your answer to the nearest centimeters. Now, I know you could be tempted when you see maximum height. You could be tempted to think, oh, are we going to differentiate now? Well, the good news is that you're not differentiating because it's 1 Mach. Okay, I don't see how you're going to differentiate something like this when it's just 1 Mach. So we came up with a solution that says x equals 2 to the power 2 over 3, 1 minus cos 2t, 2 over 3. And you are told to find the maximum that this x can ever be. You don't need to differentiate. If you look at this, can you tell what the maximum this guy would ever be? The maximum a cosine function would ever be is a 1. A cosine function would never be more than a 1. And the minimum a cosine function would ever be is -1. It would never go lower than that. So this value can either swing from +1 to -1. Okay, that's the way it swings and back. All right, the song at the background is really, really awful. It's sad. It's a sad song. I don't know how anyone would listen to that. Uh-oh, no, skip. Okay, we always skip ads. No one listens to ads. I don't have ads on my channel. I don't like ads. Right, so When this is at plus 1, that's 1 minus 1, which gives 0. Everything goes to 0. That means the lowest height would be 0. But when this is at minus 1, what you have is 1 minus minus 1, right? And that looks like it's going to give us a positive. So that's the highest you can ever get. So it becomes x maximum would be 2 to the power 2 over 3 into bracket 1 minus minus 1, 2 over 3. And that is 2 to the power 2 over 3 times another 2 to the power 2 over 3. And that gives 4 to the power 2 over 3, right? And that gives you 2. Oh, no. That's not 2. That's just 4 squared, which is 16, and then the cube root of that. I would leave my answer like that. I don't know if you understand what I'm trying to say. Or have I? Yeah, that's correct. All right, so that's the answer. And we go on to the next question, 16. And this question is just few marks to it. It says, a student argues that when a rational number is multiplied by an irrational number, results will always be an irrational number. What an argument, I'll say. Okay, so identify the rational number for which this argument is not true. So you've got a student who walks up to you and says, when you multiply a rational number by an irrational number, your answer will always be irrational. Okay, so Jacob walks to me and says, rational times irrational would always be irrational. And I think he's being irrational here, because what if you tried... Okay, I'll give you an example of what he's trying to say. A rational number, for example, could be 7 or 7 over 2, for example. An irrational number could be a number like pi, or a number like root 11, something that doesn't ever have a real definite number, or root 5, for example. So he's saying that when you times things like this by irrational numbers, your answer would, like for this one, it would just be 3 root 5. For that one, it would just be 2 root 11, because you cannot really get the number out of that. For this, it would just be 7 pi over 2. You cannot get rid of the irrational. It doesn't become rational. But why do I think he may have been making a mistake with that generalization? Because if I decide to use a rational number of 0, of course, you agree 0 is irrational. You would agree with me that 0 is rational, right? Because we know what it is. It's 0. And you multiply that by an irrational number, pi, you're definitely not going to get 0 pi. You're just going to get 0. So this is rational, irrational, and the answer gives rational, not irrational. So he must have been wrong. He must have failed with that generalization. So that's the irrational number, this one, for which his argument would fail. Okay, now the next question says, prove that the student is right for all rational numbers other than 0 that you've just identified for us. Right, I will do that, no problem. So apparently he had a point, really, except that 0 was not going to help his argument, but every other thing would work for it. And that's why you need to be specific when you're saying something. Don't generalize. So let's argue that let A be irrational. Okay? Let B be rational. Okay? Is everybody happy? Now, let's have A as irrational. What I mean by that is we cannot write A as a fraction. It has to be something we cannot really quantify. You know, irrational numbers, for example, E, pi, root 7, root 11, numbers like that we really don't have a way of saying it's exactly 2.79 or stuff like that. numbers that cannot be written as a fraction. Most people think that pi is 22 over 7, but it's not. You can Google it. Pi is not exactly 22 over 7. It's just a close approximation. Pi is an unending decimal number. So, if b is rational, therefore, b could be written as, let's say, c over d. Right? But a cannot be written like that. A times b, let a times b be rational. Let a times b, let ab be rational. So this is called the reverse, the inverse proof. So you're proving the reverse now. You're trying to assume that he was wrong, and this is actually what should be. Then it means that a times b would give us another fraction. We can say p over q. Because this is how we know something is rational, when it can be written as a fraction. So if ab could be rational, then it could also be written as a fraction. But a itself is not rational, so a cannot be written as a fraction, right? But if we go back to what b ought to be, c over d, it means that what we have there is a times c over d equals p over q. Now let's let a be the subject now. So let's push everything else to the right hand side and leave a alone. Don't forget, when you're doing cross multiplication, you can only go in the diagonal. So d would go there, c would go there, a stays where it is. So a becomes p d over qc. Now this is definitely another fraction, m over n. And then we come to say, why? This is a contradiction to what we started with. We said let a be rational, and then we assumed that ab could give us something rational if b is rational, and this ended up with something that tells us that a is actually rational. So we have reached a contradiction, which means that we shouldn't have made this assumption in the first place. And that's how to prove that it's going to be always irrational for every other rational number. Okay, that's just 4 marks. I'm glad, because if you find that difficult, then you can just run away. Alright, so we are at the last question now. You have no idea how excited I am. Now this is for 6 marks, and it says f of x is sine x. Okay, so f of x is sine x. Use differentiation, not the normal one that you know, but from first principle, to find the derivative of pi over 6. From first principle. Now do not get too worried about that, because you've got your formula sheet right beside you, and it's been said in the formula sheet that I don't know if you can see this. Let's try to get it closer and closer. Now that's not clear, is it? Okay, I'm just gonna adjust the focus if you don't mind. 1 second. Are we there? Yeah, good. Uh-oh, where is it? Okay, there it is. Look at that. Look at that. Did you see that? It says f prime of x from first principle is given as limits of f of x plus h minus fx over h as h tends to 0. Do you see that? It's on your formula sheet on page 5. So don't get worried. Just write that and we would go through it together. Okay. So it says, let's just adjust the limit, the focus back. All right, have I lost it now? Good. So by first principle, just stating what's written there in the formula sheet, f prime of x would be f of x plus h minus f of x over h, the limit of all this as h tends to 0. Now we don't have x, we have pi over 6. So we're going to write pi over 6. So f prime of pi over 6 will be limit as h tends to 0 of f of pi over 6 plus h minus f of pi over 6 over h. Now we don't need to keep writing f because it's sine. The function is given to us as a sine function. So therefore f prime of pi over 6 means limit as h tends to 0 of sine pi over 6 plus h minus sine pi over 6 over h. Okay, there is so much I wish to tell you right now about this question. There's too many things to apply, and you would notice it's so easy because it's just is. Sine pi over 6, you can check that on the calculator. You'll get a number for that. That is usually one second. Sine pi over 6. Pi over 6 is 30, that's 1 over 2. Okay. So we have to do limit as h tends to 0 of something over h. Now let's break this down as we do with trigonometry. You have sine a plus b, and from your formula sheet again you would see that sine a plus b would give you sine a cos a sine a plus b should give you sine a cos b plus cos a sine b. So in other words, we can do the same for sine pi over 6 plus h, and that's going to be sine pi over 6 cos h plus cos pi over 6 sine h, and then you have the minus sine pi over 6 over h. Okay, we know values for these guys. Cos pi over 6, we know the value, we know the value for that. So we can use them. So the limit as h tends to 0, sine of pi over 6 is half, so that's half, and cos h is just cos h. Cos pi over 6 is root 3 over 2, so that's plus root 3 over 2, and sine h is just sine h, minus sine of pi over 6, which is just half. Alright, we are going to divide each of them by h just to split this fraction. So that's limit as h tends to 0 of 1 over 2 cos h over h plus root 3 sine h over 2h minus 1 over 2h. Okay. Okay, and now that we are at this point, we could do something. We could bring this, I shouldn't do that. I'm going to show you something. This guy here and this guy there could be brought together. So if we bring them together, we have limits, and you may wonder, why am I bringing them together? Because I think they are the same, to be honest, and they are going to cancel out. So that's the only reason we're bringing them together. So half can be outside the bracket. We can have cos h minus 1 over h, okay, and then you have plus root 3 over 2 sine h over h. Now this is the point where everything becomes so easy. If you go to your formula sheet, we have approximations for sine h when h becomes very small. So limit of whatever as h tends to 0 means that what happens when h becomes very small. And in the formula sheet, and we used that earlier in one of the questions before now, we know that when h becomes really small, we can approximate sine function. I'm just trying to find it. Alright, I can't find some papers. I cannot find some papers now. Okay, I can't find some papers. But then what it says is that sine h would be h when h is really small. Okay, when h is really small, sine h is the same as h. So sine h would be the same as h, and they would cancel. When h is really small, cos h would be 1 minus h squared over 2. Okay, and so if you throw them into that, you'd have 1 over 2, 1 minus h squared over 2 minus 1 over h, and you have plus root 3 over 2 h over h. That's the sine h that has become h. Okay, are we back to, is the focus okay? So I expect this one to cancel that one. I expect this h to cancel that h. By the way, this bracket is for that, and then this is its own bracket. Okay, so 2 times 2 becomes 4. H cancels the power there. So you have minus h over 4 plus root 3 over 2. Now this is limit as h tends to 0. So when h becomes 0, that becomes h over 4 becomes 0 over 4. So the only answer you have left is root 3 over 2. And that is your f prime, that's the f prime of pi over 6 for sine function. Okay, I know that this last bit was a bit tedious because of the fact that we were going from first principle. We applied trigonometric identities, we applied trigonometric approximations, and we also applied limits. So you might get confused about that, but I would tell you that if you calm yourself down and look at this all over again and try it on your own, you would work it out so easily, and you'll be surprised how easy it could be. So that's the end of the paper 1. I'm so excited that I was able to finish it. I will be going now into paper 2, and then after that, subsequently, paper 3. So paper 2, which I have here, well, it's an interesting paper, I must tell you that. I can tell you that right now. Okay, we'll be going into that in the next video, and hopefully you would have so much to prepare with for the exam, and after this we'll try to catch up with normal revisions. Okay, I need to get you all up to speed, but remember, if you have questions or queries or corrections to make on my solutions, feel free to go on Skype and message me. Just drop a text and I'll reply your text, and if it calls for lessons like tutorials, I would be happy to deliver. Until next time, when I'll see you all, peace out and enjoy the rest of your day. Bye bye.